that we have to increase one period more for this chapter, surface area and volume. So today we are at the 6th day, and today we will complete this chapter. Only 4 sums are left, so I don't want to speak more. Let's start the sum. We'll start from question number 6. Okay, so read question number 6 first. Exercise 13.3. How many silver coins? 1.75 centimeter in diameter and thickness is 2 millimeter. Okay. Have the diameter 1.75 centimeter. So what will be the radius? 1.75 by 2. And thickness. Question: silver coin must be melted to form a cuboid of dimension. Now one cuboid has given. Dimension means the length, breadth and height of the cuboid has given. What is the length? Length given 5.5 centimeter. Breadth is 10 centimeter and height given 3.5 centimeter. This is length, this is breadth. Question is that how many like this silver coins are required? By seeing the measurement, the thickness and the radius, you can better understand. Silver coin is actually a cylindrical shape. The thickness of the silver coin is actually the height of the cylinder. Let us say that n number of silver coins should be taken to get this cuboid. So we are just taking, let n number of silver coins required to form the cuboid. So according to question, n into volume of one silver coin equal to volume of cuboid. Now one thing you just see here, everything is given in centimeter. Everything is given in centimeter, but the height has given in millimeters. So we are just changing this height into centimeter. It will be 2 by 10 centimeter, plus 0.2 centimeter. So this is actually height. Now, n into, so this height and this height should be different, making it capital H. Capital H equal to this one. So n into volume of one silver coin. This is a cylinder, formula is pi r square h. Volume of cuboid, formula is LBH. Now putting the values, pi means 22 by 7, radius 1.75 by 2, that whole square, h is 0.2, L means 5.5, breadth means 10 and height 3.5. I think you can calculate it to get the value of n. So this calculation part you just do yourself to find out the value of n, and then you write the final answer. Therefore, that many number of silver coins are required to make that cuboid. Okay. So now I will move to question number 7. Question number 7. A cylindrical bucket 32 centimeter high and with a radius of base 18 centimeter is filled with sand. There is a cylindrical bucket. The height of the bucket is 32 centimeter. The radius of the base is 18 centimeter. Filled with the sand. This bucket is emptied on the ground and a conical heap of sand is found. So this is full of sand, and this sand has emptied on the ground to make a conical heap. The height of the conical heap is 24 centimeter. This height is 24 centimeter. Find the radius and slant height of the radius we are taking capital R because this one we have here. Achha, one thing just to see here. One thing just to see, the volume of the sand present in the cylinder should be equal to the volume of the cone, because this sand only emptied on the ground to make this cone. Okay. So let the radius of the cone equal to capital R centimeter and slant height equal to L centimeter. Now, according to question, volume of cone that is equal to the volume of cylinder, because from the cylinder only the sand has taken out to make the cone. Volume of cone, what is the formula? 1 by 3 pi r square h. This one is just keeping as capital H. And volume of cylinder is pi r square h. Now putting the values, pi can be cancelled from both sides. Capital R is, we have to find out, h is 24, 80 square 30. I think you can calculate it to get the value of R. After getting the value of R, as you know the value of h, so you can find out L. So R you find out yourself, okay? And then you write the final answer. Therefore, the radius of the conical heap is that much centimeter. Then you have to find out what slant height. So again you will write like again. Then slant height equal to L. What is the formula to find out the slant height? You know, a square plus r square. The value of h you know 24. So 24 square you can write here. And r square value you are getting from here, so that value you put here. Then you calculate to find out the square root of it to get the value of it. So that plus centimeter will be the length of the slab height. Clear? So I think this part you can do yourself, calculation part. And everywhere after completing the calculation, write the final answers, because for missing the final answer, marks question is there. Okay. Now we move to question number 8. Now question number 8. Water in a canal 6 meter wide and 1.5 meter deep is flowing with a speed of 10 km per hour. So the width of the canal is 6 meter. Depth of the canal is 1.5 meter. And water is flowing through it at a speed of 10 km per hour. How much area will it irrigate in 30 minutes? So the water just flowing on the ground for 30 minutes. Question is that how much area it will irrigate? How much area it will irrigate? If 8 centimeter of standing water is needed, if 8 centimeter of standing water is needed, just explain the sum again. This is a canal. Through this canal, the water is passing at the rate of 10 km per hour. The speed of the water is 10 km per hour. The width and the height of the canal has given, and this water is passing through it, falling on a playground, falling on a ground to irrigate the ground for 30 minutes. So whenever the water will fall on the ground, for that stagnant water, the water will reach some height. The height has given, the standing water height has given 8 centimeter. Question is that how much area it will irrigate. One thing I must say here, though I have drawn the diagram like this, whenever the water will fall on the ground, it will not make any particular geometrical structure. So, to make it more simplified, suppose the water has came on the ground with this structure, and the height of the water, that is 8 centimeter. Whenever water will fall on the ground, so it will reach some height. The water should have some height. This height has given 8 centimeter, but the area how it looks I don't know. Now one thing you just you have learned in the first period whenever you have done that if I know the base area and height, by multiplying base area into height I can get the volume. Correct? So what is my work now? First of all, choosing 10 kilometer as length. First of all, just decide 10 kilometer is not given the length of the canal. But what we are doing, we are just choosing 10 kilometer to be as length. 6 kilometer as breadth, it has already given. 1.56 meter as breadth and 1.5 meter as height. So choosing 10 kilometer as length, 6 meter as breadth and 1.5 meter as height, if I find out the volume, that will be the volume of water passes through the canal in 1 hour. Because the speed I have chosen as length. 10 kilometer I have chosen as length. But the 10 kilometer is passing through the canal in 1 hour. So whenever I will choose 10 kilometer to be as length, 6 as breadth and 1.5 meter as height, and if I find out the volume, that volume will be the volume of the water passing through the canal in 1 hour. So volume of water passing through the canal in 1 hour we are getting. So for 30 minutes how much it will be? Easily I can find out because half an hour means 30 minutes. So 30 minutes how much water is passing through the canal we will get it. So that water came on the ground and has taken some area with some height 8 centimeter. So this base area into 8 centimeter should be equal to the volume of the water came in 30 minutes. So by solving I will get the base area. Correct? But before of that I have to change the unit. So first of all we are writing like this: volume of water passes through the canal in 1 hour. 10 kilometer into 6 meter into 1.5 meter, because it's a cuboid shape, length into breadth into height. Changing all the units in the same unit, kilometer to meter. Keep it like this, no need to do the calculation. So this is the water passing through the canal in 1 hour. Now we know 30 minutes means half an hour. Therefore, water passes through the canal in 30 minutes. What will be? Half of this. Got it? So this is the volume of water passes through the canal in 30 minutes. Now this water is coming on this ground. So what will we write now? What I have told in question, let's see. How much area will it irrigate? According to question, before of that, it is 8 centimeter we have to change in meter. So 8 by 100 this one. According to question, area of irrigation into height equal to volume of water passes through the canal in 30 minutes. Area of irrigation, that one you have to find out. Height how much? 8 by 100. Why I have changed to meter? Because this one is meter cube. So this is the volume of water passed through the canal in 30 minutes, which has came in on the ground to cover this area with a height of 8 centimeter. So this will be equal to this. Now I think you can calculate it to get the area of irrigation. So area of irrigation, this 8 by 100 you take to that side, calculate it and find out the area. And the answer must come in meter square. Okay. If the answer is too much bigger, then you just change it to kilometer square. That is totally depends on you. What will be the situation, depending on that, accordingly you will do the work. And after that you have to write the final answer. Therefore, the area of irrigation is that much meter square. Again, I am saying if the meter square is a very number of digits, then you just change it to kilometer square. Okay. So I think you understand this one. Now we will do the last sum of this exercise and this chapter 9. A farmer connects a pipe of internal diameter 20 cm from a canal into a cylindrical tank in his field, which is 10 meter in diameter and 2 meter deep. So the cylindrical tank. This is the cylindrical tank which is 10 meter diameter. So I can say the radius 10 by 2 meter, that is 5 meter, and height is 2 meter. Farmer connects a pipe of internal diameter 20 centimeter from a canal into a cylindrical tank in the field. The water flows to the pipe at the rate of 3 km per hour. Okay. So this is the canal. This is the canal. And the pipe has adjusted this. The water is coming through this pipe and coming in this cylindrical tank. This pipe having the internal diameter 20 cm. So what is the radius of the pipe? Radius of the pipe is coming 20 by 2 cm. So it's coming 10 cm. As everything is meter, so we are changing it to meter. So 10 by 100 meter. So 0.1 meter. And the water is passing through the pipe at the rate of 3 km per hour. So speed of water at the rate of 3 km per hour. In how much time will the tank be filled? Question is that in how much time this tank will be filled? First of all, I find out choosing 3 km to be as a length, what can be called as the height of the cylinder. So choosing 3 km to be as the height of the cylinder and 0.1 meter to be as the radius, we find out the volume of water passing through the pipe. As I have chosen 3 km to be as height, this question is very related to the previous one. As I have chosen 3 km to be as a height, what can be said as the length of the pipe? Same thing. So if I find out the volume of water passing through it will be the volume of the water passing through it in 1 hour, because 3 km per hour was the speed. 3 km is not actually the length of the pipe. And if you generally think, it is not possible also a pipe of length 3 km which is passing of water in the cylinder. So the pipe length I don't know. But the water is passing through the pipe at the rate of 3 km per hour. So if I choose 3 km to be as the length of the pipe, if I imagine it, then choosing 3 km to be as the height and 0.1 meter to be as the radius, if I find out the volume, that will be the volume of the water passing through the pipe in 1 hour. That water is coming here. Okay. So question is that how much time is required? Because what is the question? How much time it will take to fill the tank? Now I find out the volume of the tank. If the volume of the tank I divide by this volume, then how much time is required I get it? So first of all we are finding out what is the pipe. Volume of water passes through the pipe in 1 hour. Pipe capital R square, capital H you are writing 22 by 7. Pi you just keep as pi only. R square means 0.1 whole square. H is 3 kilometer. Correct? It is 3 kilometer. So you have to change to meter. Since 3 kilometer equal to 3000 meter. Because everything is meter. So this much water is passing through the pipe in 1 hour. Now volume of the cylinder. Volume of cylinder. Formula is pi r square h. So pi into r square means 5 square and h is 2 meter square. Now we find out therefore time required to fill the cylinder equal to pi into 5 square into 2 meter cube by this one, pi into 0.1 square into 3000 meter cube. That much hour. Meter cube will be cancelled, pi will be cancelled. So 25 into 2. Point will go to upside as 10. Square is there, so that's why twice I have written. 1 square no need to write. This much hour. So it's coming 5 by 3 hour. So it will be 1 whole 2 by 3 hour. That's in 1 hour 2 by 3 into 60 minutes because fraction will not give. 320 by 60. So the answer is coming 1 hour 40 minutes. So I think you understand this one. No confusion is there. With this, our chapter is completed. So only one chapter has left, that is statistics. So next day we will come with this chapter, statistics. Thank you all, and within that you just do some sum from outside, and if you are facing any problem, you may can consult with me in our doubt clearing class.